So this is the inside the call UI where the three things happens when we call user A calls user B. So when user B accepts the call, it is redirected to the calling screen from inside the app. And since user A call user B, so when user B comes to the calling screen, it shoots the event to the user way that I am inside the calling screen. Now stop ringing. That event is going to the user way A, and user way A also is redirected to the. So they join from the call. The exchange the token for the call and handshake. It is called handshake. They exchange the token or handshake for that, and calling is happened at the right. Here in the calling screen, we have the number of buttons like mute, converted audio into the video, and a speaker. So why what we need to means consider while we redirect into the calling screen or while we creating a headset, we always need to enable video permissions or initialize. When we initialize the call, we always have to enable video permissions so that we can let a converted audio call is to the video call. So that is the we need to consider in the mind while designing our audio system, VoIP calling system. And yeah, there is a socket events when we decline the call. This same event is received at the other end. So they also dismisses or leave Agora session and dismisses the call and leave the calling screen as well. So this is the basic flow how that these things work. We will code it later. Let's go further. For VoIP architecture, real-time channel, that is a socket IO equivalent like Firebase. Any real-time channel that we have to implement for the real-time communication. This real-time channel is basically used to the signaling between the peers to peer, like initiate, accept, decline, and number of events we can shoot from here to there. Inside call, keep alive. That is very important for the maintain the extreme scenario. Extreme scenario like if there is an ongoing call and if user uninstall the application, so you don't have a means what we can say, you do not have the access or you do not know is the user decline the call, because since user install the application, you do not have a what we can say signals for the at the other user end key that user ended the call. So in that case, we use keep alive system. Keep alive finishes the call if they didn't get it for the, let's suppose, 30 seconds. 30 seconds after 30 seconds, it always disconnect the call by its own. We can disconnect. In a real time communication, we use socket IO. For push notification, we use one signal. FCM. We can use one signal here. One signal and FCM are generally used for the signal normal activity. In case of VoIP notification for the Apple separately, we need to hit Apple VoIP notification API. For the Android side, we just shoot a high priority one signal or FCM notification. I use generally one signal over the FCM because although one signal use under the word FCM, but it has a single listener to maintain the background killed and foreground services. So I use prefer one signal for the notification. And so what we have to do, we have to shoot the notification for the calling, and that notification is based on the platform specific. If it is a iOS, that it is shoot from the iOS API or what you can say Apple API, and if it is from the Android, it is one signal priority notification. Okay. So basis on those notification, we maintain the that we shows the or launch the activity inside the OS level. Since it is a silent notification, it is not visible on the to the user. From that notification, we shows the UI to user. That is the how the things work in the VoIP. Native modules come in next in the picture. For yeah, so as we discussed, for the we have to show the UI as per the notification. So what notification, what UI we have to show, it comes under the native module. Since the notification is listened on the native side for the silent notification type, it is not need listen if the app is in a kit listed on the JS thread. It is always listen on the main thread or native thread. So what we do, we create a UI for the Android. We create a native activity and activity launcher for the Android side, and for the iOS side, it is a predefined UI there. So we have to call those that method. So what that native use, that use two services under the hood. For the iOS, it use CallKit, and for the Android, it use connection service. Okay. Then we use media service layer called Agora. for the real-time token exchange after the call is established. Agora provides us the tokens to exchange the call. It is good for the security encryption layer for the particular station. So deployment purpose we can use Agora since it provides I think 1,000 minutes of for free. And although it use WebRTC under the hood, but since it provided minimal operations to perform these things, so we can use that. Uh, if we want, we can use later WebRTC implementation. How these things work in a WebRTC if we don't use Agora. Let's go to the next slide. Yeah, as we discussed that calling is the global in the app. It is not restricted to particular screen that we discussed earlier. Like this is the WhatsApp screen that shows our particular call UI. But what happens when we click on the button at the top left? It redirects us to this screen. Okay, so it is a global wrapper. So whenever whatever screen you are in the application, you always listen the call or exchange the token or exchange the communication. So we need to create a when we design it in the React Native side, we need to create a global wrapper. That wrapper, it's a wrapper for the whole application. It holds the context of the whole application. So where it is showing banner inside the application, so user can minimize the call and mute from the top banner is do not need to the calling screen, and it is much more I can say good way to maintain the calling. Although Agora established call you can listen to all over the application, but what if in case the user leaves that call, do not have any way to access the cut the call or mute the call. So we need to create a global wrappers from which we perform the operation. So the services we also implement, Agora is also a global wrapper service. So we can mute or unmute or cut the call or decline or fire the socket, even leave the Agora session from the wrapper that we design. It is a floating call banner. Okay. So there is a here are the edge cases. When a user A hangs the call, user A initiates the call, user B gets a silent notification. The native UI shows the through the CallKit or connection service native UI from the activity or the inbuilt UI from the iOS. So what if the user A ends the call? There is still the notification shows to user B. So what we have to do, if user A ends the call, we have to shoot some events to user B end so that it will not that notification that is coming or activity that is coming at the user B end should also be dismissed. So in that case, we also shoot silent notification through routing through the backend. We shoot the event to the backend. Backend shoots the silent notification. Silent notification handled natively inside the user B native code. So it dismisses the banner. Okay. If user B leaves the app when there is ongoing call between user A and user B. Okay. So this session should not be dropped. Suppose there is a scenario user A calls user B, but user B, what happens? User B kills the app. So in that case, the call should not be disconnected. In case of Android, in case of iOS, call is disconnected because iOS do not allow to perform any task when app is in a kill listed. As it is a iOS policy, we can't change that or we can't manipulate that. But in case of Android, we can do. So call should not be at end. So what we have to do that call should not be at. We have to attach a foreground service in that case. So what happen when the call is initialized between A and B? We have attached the call foreground service. That foreground service is the real time listener that we real time listener that we are on call. Don't disconnect or don't since the JS thread is closed, so don't disconnect the call. Call should be managed. So all should be run in a real time. So we have to manage these things also natively. Connection service is responsible for this thing. Okay. Yeah, these things we'll discuss earlier. Android foreground service and iOS PushKit plus CallKit. Okay, this renders the UI for that particular time of period for the calling system. So as we discussed, socket in a killed state. If socket is on the JS thread, it will not run even in a killed state. So we have to manage the through the foreground service, and Agora listener also Agora service also should be implemented in the natively on Android side. On a killed state on iOS there is no call working, so we do not do anything in the killed state in the case of iOS. Let's move further. So what we do next? Okay, it is just an architecture overview, and I just explain what and why we are using VoIP. It is just a theoretical way or things I covered theoretically, but later we discuss in a production way, because production code is more best way to explain how the things work, and not just the code. Explain with the code is the way to how the things work. So three important components we use later. There's a TypeScript, that is a signaling layer. TypeScript we use in a React Native on a JS thread. So what TypeScript consists of? It consists of signaling layer like socket events, one signals, and global context, global wrapper, that is shows the bubble UI whenever the user leave calling screens. So that is maintained under the TypeScript. On shift side, the second component, that is shift, that is used by iOS. In there is a separate class for the calling, that is a call kit, and push kit for the generate the token that is required for the established call, that I talked earlier. That is the I protocol, internet protocol. That is the token that is generated from the backend choose the notification of the call type. So we need to create a native module for that. That native module is directly and bridge that native React Native. So we get that token and we send that token to the server. Server shoots VoIP notification to that token, and the other user established a code. Okay. Kotlin is used in the Android side for the foreground service, connection service. Foreground service is a service that attached during the calls between the user and user B. We have to establish those service, otherwise call is not connected at all. Oh, call is connected, but we know visual representation is call is going or not, because we have to monitor in the notification banner that something is going on that app, so we have to attach foreground service for that. And unlike likewise in iOS, it is use a connection service. As iOS use CallKit, it use connection service, and we have to create bridge for also for that, listen for those accept and reject button that we use to show, or we show on the activity UI for the calling. So no theory, only end. This is just I explain how the end-to-end flow of the VoIP comes. In the further videos of we implement how the VoIP is connected, how the things is work in a real time. And as far as I know, it is the most advanced way of the communication for the VoIP. There is no SDK to establish this kind of stuff as I researched so far. If you find anything on your output, or your suggestion, like we have to do things like in a that way, just to take an example, like we are implementing native module in this. So if you find no, we have to implement turbo native module, so we can also consider that things to make things more advanced as we are doing right now. Okay, so we'll discuss it further and we'll create the things later. Here we design all things in a separate manner. So each concept covers has its own influence, like socket has its own influence, its entire system. Native module has its own system. Signaling is its own system. So and combine all those things in a VoIP is own system. So we cover almost four major topics, and four major topics also and combine those major topic in a way that our connection is established. I think it's a good way to implement something in a system design. So this is